So the next step then is pretty straightforward. I'm going to open the tool which is found under Modeling Projections and is called the Project Wire tool. And basically this tool asks us to, in a first step, to select the wire or the edge profile that we've defined. So I'm going to select one of these two. And the second selection is the solid where we would like to wrap the profile on. So I select the torso, I press Done. You see here we have the imprint function activated here, and that's actually going to print the profile in the solid. And then I repeat that step for the second profile, press Done, and I can close the tool. And now basically when we hide the two polylines, we can see that we now have the profile of the loop etched into the model, into the torso phantom. The difference being now, and we need to zoom in a little bit here, is that this is no longer on a Cartesian plane, but is really actually etched into the surface of the torso. So that's basically the first step. What we want to do now is actually extract a surface in that plane so that we can actually model our antenna. So again, I'm just going to select the torso here, and under some of the sheet or surface tools that we have, you'll find the explode function, and that's just going to create basically a set of faces, and in this case the first one is actually the surface of the antenna. So we can now just basically delete these, and if I hide the torso, now you can really see that the loop has followed the same curvature of the torso model here. So that's basically the starting point. So that basically gives you a feeling for some of the new modeling tools covering the bending and operations related to interactive translation. In addition to that, we have other tools, including topological morphing, which allows us to perform similar kind of bending operations, even in 3D, but in a much more interactive or user interactive way, so using the mouse controls. So you have the combination of these two options. So in the next step, I'm just going to show you then very quickly what we can do to generate, to add a feed to the antenna, and then we're going to look at some of the new simulation settings and some of the gridding involved. So I'm now going to define a small brick to subtract from the loop to add a source element. So I'm just going to move the mouse along the edge, somewhere approximately in the center. I click once here, move to the opposite edge. Again, the mouse will detect it. And we can change the mouse and we see, okay, there's about 2 millimeters. And we click here. It's going to generate our brick. And using the subtract or the operation, we can now basically create a small gap where we can add our feeding element here. Okay, so this part is fairly straightforward here. Just going to continue now to add an edge source to introduce a driving point for the antenna. Okay, so there we have our antenna. We can basically, if we would like to change the color just to make it a bit more visible compared to the phantom model, and we can see then the structure that we have developed here. Now the last thing that you may or may want to do from a modeling point of view, at the moment we still have a surface object here for the loop. Depending on sort of the frequencies and specific applications, that may or may not be sufficient. But just to show you how you can actually convert that sheet into a solid object, again, we'll go under our sheet menu here, and we're going to choose the thicken sheet tool. And that is basically going to open a little dialog here. And here, this allows us basically to specify a thickness for the sheet. And if we zoom in here now, I'm just going to hide the torso, you can see now that we've actually generated a solid object again from this structure before. Okay, very good. So I'm just going to save this at this point. Okay, so from here we can move over to the simulation settings and have a look at some of the new objects that we've been, or features that we've been working on in this area. We're going to start, in this case, I mentioned before, we're working with a broadband antenna, covering a frequency range. We can center it about 1 gigahertz with a bandwidth of 1.5 gigahertz. In this case, we might want to increase the simulation time by a few periods, just to cover the resonances. Also, something very new, which I will speak more about later in my presentation, is the development of a armor filter, which allows early response frequency behavior estimation. And this is similar to the previous convergence detection that we had, however, with a much better performance in terms of simulation time and even in accuracy. But I will show you some material about that on some slides after. So the next thing that I'd like to show you then is related to some of the material work that we've been working on. In a first step here, we can select our antenna and just turn it to a metallic object. But now what we can do, if we would like to, let me just go back here. Let's assume that since we are simulating a broadband antenna in this case, we actually would like to model the dispersive properties of the tissue. And so in this case, we're just going to use a homogeneous environment since we have a generic phantom. This will basically calculate the coefficients for our dispersive model that we would like to use here. Okay. Try and go back to muscle. That looks good. Okay, so we have, in this case, instead of importing parameters, we've just read them straight from the tissue database. And hopefully now when I start the fitting process, you can basically see now the input data and the fitted curve. We can say, okay, well, we'd like to reduce the target error and basically refit, and slowly we should see an improvement of the parameters or of the fit to a very, very accurate solution. So once we're happy with the behavior here, we can copy the parameters for this tissue, or in this case the dispersive coefficients, and now just in Semcad we're going to paste those properties. I'll close that here, and we can have a look now. You can see the relative permittivity and conductivity are defined, but in addition we have the number of dispersive poles along with the coefficients to initialize the models that are used for the dispersive properties there. So this is something very unique and pretty powerful in that regard. We can, if we still want to verify the behavior, we can actually plot the response as a function of frequency. So we can plot the material parameters over the frequency that we have specified. Okay, so coming back to our simulation, we've set up the dispersive properties for the phantom model. We still have the original loop in our model, which we use to generate the profile. We can either delete that or just ignore it for the simulation. Both have the same effect here, so I'm just going to disable it. And we've defined our sheet as, or our loop as being a metallic loop. So everything else should be quite straightforward here. We have our source parameters, which the default is sufficient here. We don't have any lumped elements. Sensors are fine with the default values here. And the last thing that I'd like to show you here is just some of the new parameters that we've been working on. So we have introduced one or two new concepts with the 14.8 release. Probably the most significant concept is the idea of what we call a grid template. So in the previous versions, we used to refer to something called a mode, which basically defines or carries a set of gridding parameters for a region. So now basically what we've done is we have called these templates now. One of the main reasons for that is that in addition to the predefined templates, the customer or user can actually have their own predefined templates. So you can customize templates, and this is very useful if you have certain scenarios that you simulate repeatedly. You can have predefined settings, and it's very easy to assign those. So we'll have a look at those steps. Another thing that is very significant is that we have decoupled certain parameters that were present in the previous versions, so the dependencies that existed. One example of that is the unit, which used to be a global setting, can now be set